talk more about the virtualization, how that impacts things, and how do you actually try to figure out what's happening underneath that. So that's it. Like, we all work with Postgres, and we know that the best way to get performance out is first tune Postgres. And I know, how many of you have done Postgres tuning already? Right? It's pretty easy. You make sure that you have all those knobs in the right position, and soon what happens is you're flying like an airplane in an open sky, which is how you would like to make sure your database server is running. And what happens when you go through the cloud? You are going through some turbulence. It's kind of like an analogy to flying, right? Everything is going well. You hit clouds, and you have turbulence going around. And basically, what you want to do is figure out what is happening and move on from that. So that's kind of the idea. So quick poll out here. How many of you actually use a database in a virtual environment? It's pretty nice. Is it on VMware platform? OK, cool. Great. Are you on Zen or? Zen and VMware. Cool. OK. So that's kind of the question that most people have. Like, why do you want to virtualize database? And depending on who you talk with, you get the benefits. I think it pretty much amounts to few standard things. Like consolidation is a big play, right? Ease of administration is another thing that I've found. Like most people say, why do they want to run databases on virtual environments? And I think it's really the CIO and CTOs who thinks about the OpEx space and time savings that they can get by moving a lot of this database servers into this virtual platform, so they get things to move around quickly and do, you get the ease of use of moving, upgrading the hardware and other things. I'm not going to sell you that. To me, the only thing that's really worthwhile is my last bullet. What I found is it's actually a pretty hot technology that I can put on my resume. So anyway, this has been something from my own experiences. Like, if you asked me probably like 7, 8 years ago, what is virtualization, I would have given you emulation as the answer to that. But today, I think this has changed. I think if you look at the overall layout in the industry, there are different ways how people do virtualization. Sometimes you have an abstraction where, this is where you kind of like say, you're trying to do a lowest common denominator on the x86 hardware layer that every chip performs or every chip supports, and you only do some sort of abstraction to that layer. That's one way of saying that it's virtualized. The other way that you would often find that people do a lot is they have these huge systems which they cannot figure out how to use it well. So what they do is they do kind of like divide those resources into smaller groups, which your OS can scale to pretty well. They are aware of that, and that is one way people do virtualization. The third thing is like the emulation mode. Like you have some weird chip, and you only have software that supports x86 or some weird CPU architecture, and that's the way. Also known as virtualization by emulation, like you are emulating a chip architecture on a way different architecture underneath that. So that's one way. That was actually my first exposure to virtualization. And then this is the thing that you need to avoid is the exaggerated virtualization, where you have a uniprocessor system underneath that, and it shows that you have 64 CPUs running on that system. And that is out there. There are some virtualization companies doing that. So to me, so this is how I kind of like say, when people say virtualization, I try to first figure out what the technology does to get an understanding, like, how does that virtualization technology work? The other thing is, like, once you start with virtualization, you need to be aware that whenever you do queries on those systems, take it with a grain of salt. The best cases, you get the truth out from them. But most of the time, they hide that truth, right? You don't really, the reason they have virtualization is they don't want you to know what is underneath that. So you don't get that information back through your guest OS. The worst case that you have out there is it lies, right? Like the classic example I just gave you is like, you really have one vCPU or one CPU in your underlying system, but it's telling you you have 64. Those are the things which are actually hard to catch from guest level, but that's why you have to kind of query your platforms. Not directly using the framework that you get, but you actually talk with the people who are running the show in that environment. So coming back, like, the classic thing, like what we care as Postgres. Typically, you have 4 key resources that you use in an environment. You use the CPU, you use the memory, you use the network, and you have the disk. So pretty much, most of the virtualization technology does this. You have this 4 key resources in your physical hardware layer, and they somehow have some sort of magic around it, and they give you those same 4 resources back to you as a database service that is running on top of it. Now, how they do that can depend on my previous slide. They have various ways to fetch things out there, but once you know what they are showing you back, once you understand that well, you now have a better understanding of your actual underlying resources that you have. So that said, like I said, one of the key things I want you to do if you're running in a virtual environment is to talk with virtual administrators, or the new term for them is cloud administrators. This is kind of like something I cooked up because now, in the past, I think I used to talk with storage administrators, system administrators, network administrators. I think that there is a new guy in that mix known as the cloud administrator. So that is something that you want to buddy up, take him out to lunch, and poke him. Like, tell me what system do you use underneath that, so I am pretty much, confident that I'm getting what I think I'm getting. So typically, one of the things I want to do is when you are deploying Postgres database on a virtual environment, most of the time you do capacity planning, right? When you do capacity planning, you want to understand well, like how much CPU resources you need, how much you go through this phase to figure out the right configuration of your system. That said, one of the other things I learned pretty quickly is you don't want to now do exaggeration on your own requirements for the database. I sometimes did that, like, I'm a performance guy. I always want the biggest system you can give me. I found that that is not the right way to do things when you are on a cloud, because they will give you that, but you will see penalties on how they implement those structures to give you that. And we'll try to go more in detail about that. But one of the things I learned is basically make sure that you ask for exactly what you need for your workload. So if you think you can get by with two CPUs, this much RAM, that should be the values that you go back to them saying, like, you need a virtual system which has these resources. If you try to double up, apply the old rule, ask for double for what you really need, that thing may actually hurt you in this cloud environment. And I'll try to go more in details about that, but that's one of the things to learn about. The other thing to kind of like make sure is, like, you do talk with your cloud administrator and make sure that you are aware of how much overcommitting they do generally. So typically most organizations, when they work in this kind of virtual environment scenario, they have what they call as the projected or the target overcommit ratio, right? You would see that most people have somewhere in between 10 to 30% of overcommit. Like, whatever resources they give you out there, they would potentially give you 30% more than what they really have underneath that. And this is kind of like a ratio that I think I'm hearing more and more things, people telling me that, we have a target overcommit ratio, which is somewhere about 30%. When they say 30% it's really 130%. Like, they give out VMs if you total them up, it's actually 130% of the actual underlying resources. So once you ask that, you now have this thing in your mind, like, whatever I'm getting, maybe it's really 1/30% of what is really underneath that. This actually helps you quite a bit when you're doing some sort of performance tuning on top of that. And while I'm on this topic, the other thing I want to say is, like, this is a good time, like when you're designing databases for these virtual clouds, try to maximize the number of disks you have. Now if all disks are virtual, why just ask for one disk? We'll try to go more into detail about it, but this is kind of like learning. Yeah.
Well, you mentioned separate for the wall and the PG data, which you put the operating system on a third disk?
Yes. Yeah. So that's the idea. Multiple disk, way multiple disk. Like, try to go, if you're trying to do something out here, there are certain advantages that you don't see that right at the beginning. But as you grow, like, it's hard to decide on things right at the very beginning. Like I don't know how much my data would be, say, 2 years from now. The best way to avoid those kind of things is always start things by separating them on maximum number of virtual disks right from the very beginning. And that would be a strategy that would allow you to grow well. Yes. Yes and no. And we can go, so I'll kind of give you a quick thing on how. So most of the virtualization technologies also give you virtual disk. And one of the things that they don't tell you is they actually monitor those virtual disks and how you're using them. And based on your usage pattern, they may actually have some smart things going on. It's like, this thing is really hard. I'm going to move it somewhere else. And they would move the whole virtual disk underneath you to probably a better storage for that. So by splitting them out in the first place itself, you are actually helping them to make those intelligent decisions that they may not even ask you in the first place, right? If you put everything in a one big virtual disk, you have this I/O pattern which is known. Yeah, big deal. There is no way you can tune, the cloud administrator can look at that and tune it for you. But if you separate them out in the first place, then now you have these different I/O patterns which the cloud administrators thinks, like, this virtual disk is really getting hammered by this random write, so I'm going to see if I can move it somewhere else. Or this log file is really sequential writes only. I think I should move them to a system which actually has a lot of write cache on it. So, by spreading them out into as many virtual disks you can do that, you are actually you are actually doing a favor to yourself. You actually get better disk performance, even from the guest VM layer. I mean, one of the things I found is, like, by using this strategy, I'm actually avoiding, I'm having less contention in my file system. But that's a side effect that, you get with this strategy. But the real advantage that you get, which would be hidden from you, is, like, there is a cloud administrator guy working underneath you who is going to move things around for you. So the next thing, again, so this is now, we talked about how the CPU and sizing goes. The next layer on top of that is, like, when you're trying to, create a virtual server for you, you also have choices. Like, everything is emulated. So you're emulating the network NIC, you're emulating the CPU. So what you also want to do is figure out the right emulation or the virtual server things that you get, which your guest VM supports pretty well. We all know that out of the 10 network cards, I know that these two particular kinds will probably give me the best performance out. So, I know there are a lot of choices out there. So what you have to do is, like, for that, you actually, this is where you have to do some bit of research. You try to find out which thing works best for you, the guest VM that you're going to use. So one of the things I found is, like, the best things to do is work with the underlying vendor or the virtualization technology and look at which network emulations they support. and which ones gives the best performance out. So, well, kind of like my pet view on the working on the VMware side is what I've realized is go for something that they call as para-virtualized. Now, the term para-virtualized means is it's not a complete emulation. You actually have some small piece of real software in your guest also, which knows about that emulation, and it does some efficiency, or it has actually more fine-tuning understanding about the underlying resources. The reason you want to do that, and this can only be done if the guest, if the Linux version that you're using supports those drivers. So by doing that, what you're really trying to do is cut down inefficiencies in your system, which you cannot really control. Like, you know, your network driver may be a problematic thing once it starts running on a virtual environment. So the first thing you want to do is make sure your network driver is actually supported for that kind of platform. And maybe there is an updated driver from the vendor itself, like, oh, if you're running on VMware, here's an updated driver, and which is para-virtualized, which basically helps you to cut down everything. Like, you know, it can do some smart things of offloading some of the things back to the underlying hypervisor and save you CPU cycles. So the reason you want to do this, why, is to save on resources. So Postgres gets maximum cycles for its own needs. You don't want to, you don't want your CPU cycles to go away and do things that is not really, well, it's still part of the overall system, but you want to get maximum CPU cycles for Postgres. So these are a few of the ways you actually do that. So, you know, once you're running in a VM, what you need to do is figure out every driver and see if there is a para-virtualized driver for that. If you get that, best use those ones. And the immediate benefit you see is like your guest CPU utilization goes down. Your memory consumption overhead seems to go down. So we'll try, that actually gives you more resources for the database itself. One more thing I want to highlight is like recent CPU architectures have changed a lot, and they have also introduced the virtualization technologies in the chip level itself. So you also find that once you start using them, the CPU efficiency goes up dramatically. So those are the other things you need to figure out. Like, you know, as long as you are using more hardware-related technologies in place, you are having less CPU cycles spent in doing the overhead work, which means you have more CPU cycles for your database server. So that's it. Like, you know, whatever I talked about is kind of like, you know, crammed into this image. You have the physical resources, and you have this hypervisor stack, which is acting like the manager in between the real hardware and your OS. And you have all sorts of drivers talking through the hypervisor, and everything that you do in your guest VM is to make sure that the hypervisor does not get into your way of eating out cycles that you don't really care about. The only cycles I really care about is I get the maximum cycles to my database server so I can do maximum optimization on my you know, query performance. So there is another feature out there which is kind of like pretty useful. Say, for example, you have production servers, and you have this 30% overcommit ratio going around out there. That 30% ratio that they use, I mean, you are never exposed to that, which means that as a guest VM, it could be that at that particular point of time, you may be in a bad shape because some other VM is hurting your performance because it's doing some, there are rogue CPU cycles being used by some VM, which is really rapidly you know, taking away resources from your VM. So the term that they use out here is the noisy neighbors, right? You have other VMs running in the system that you are not aware of, and they're taking away cycles because, you know, somebody's running some CPU operations in that one. So most virtualization technologies also have what they call as like resource guarantees, and that is actually a good way to exploit that, especially for databases. I wouldn't say do this for everything, but especially for databases, you want to make sure that you have certain resources which are guaranteed to you. Like, if their target thing is 30%, then you can negotiate with them to say, give me at least 70% guaranteed, so I don't mind floating around in that 30%, or not really 70, but 66, depending on how your math works. But at least I have a guarantee that I have these resources to my VM. And this is a negotiation that you have to do intelligently, because you don't want to be a bad citizen in that virtualization framework idea, because they are also trying to make efficiency as the key thing. But at the same time, you want to make sure that your VM does not suffer or go into this resource crunch because somebody else is grabbing up all the resources up. So this is kind of like a good way that to get some the resource, what I would say is like the guarantees that you get, like the resources that you're getting, you do have a right on them. So in VMware, basically you get controls on memory and CPU. And I think the new version also has some guarantees that you can put on the I/O layer, saying like, I want to make sure that this many IOPS I can get for my VM. These are actually needed more for databases than probably any other workloads that I've seen, because most of the time what you would find is like the latencies that is created by the database query slows down everything in the middleware layer. So to get these things right, this is why this guarantees things are more critical for databases rather than, say, a Java application middleware layer. I mean, they have different problems to solve, but for most of the time that you would see, like the database queries, like if a query comes in, somebody's waiting at the other end. If they don't get back, you don't get back to them soon, they'll just wait. So that said, for Postgres developers, we all know that wall sync is kind of the most critical thing. Like, the reason you're using Postgres in the first place is you worry about durability, right? And when you write to a wall file and you do a sync, you want to be absolutely sure that the sync went to the disk. Now, that said, depending on the technology you use, that may not be true. So even within VMware, I'm aware, like, if you use the vSphere platform, it goes to the disk. Like, when you say sync, it goes to this disk. But if you use some host-based products, like which are meant for desktop virtualization, if you do a sync, it doesn't go to the disk immediately. It tries to kind of consolidate all those syncs together so there is less pressure on your laptop disk. Because those virtualization technologies are designed for laptops and not for servers. So you need to figure out, like, if somebody says, oh, I'm running this virtualization technology on my laptop and I get this great database performance on it, it's probably doing this trick, which is pretty common in laptop virtualizations, is whatever sync you do doesn't go to the disk. So you want to be, you want to make sure that if you're using a virtualization technology, make sure that this is enabled, because otherwise, it's as good as running app sync off.
What if I run Postgres on one of your appliance configurations, a package, say Linux appliance, guest OS, and I have this issue where I need to sync? Can I rely on that, or is that one of the cases like
Yes. So the laptop actually has this, depending, I think, workstation product, VMware Workstation, which allows you to play that VM. And the workstation product, by default, would have this auto sync disabled. So it would be trying to do an optimization so it doesn't put enough pressure on your laptop disk and kill it. There would be options out there, yes. I don't know about the exact options, but yes, there are options to turn to actually make sure that it behaves that way. But by default, first place, it was designed for desktop virtualization, so the defaults are all meant for desktop usage. And you don't want to learn these things the hard way, believe me. And here's another public technology that you would see that virtualization technology they do quite frequently. They tell you you have this 1 terabyte disk, right? And really, there is no disk underneath that. it says like, yeah, we have enough pool of storage out there, and whenever you want to use that 1 terabyte disk, we'll allocate you that space. So that's called that. The term that the VMware actually uses for that is called thin provisioning. So the thin provision is like you have enough space, but I'm not going to give you the whole space right now. I'm just going to give you a growing disk. The more you use, it will grow to the 1 terabyte thing. Now, from storage efficiency, that's a very good thing. But depending on your workloads, that may be a bad thing. What could happen is like that when you're doing it on, say, log files. The log files are pretty critical, right? You want to write quickly and come back. So if the log files are on a thin provision disk, the sequence is I do a write to my thin disk. The thin disk writes to the underlying storage saying, oh, I need a new block for my write now. And then that technology would say, okay, you need a new block. I'm going to zero out this space for you. Make sure it's all secured. Give it back to the disk. And the disk then says, okay, now I can take your write back. And then it says, okay, now the log has been written to the disk. So that's a long loop of things out there. So one of the ways to avoid is like if you now do have separate disk out there, you can say like, make sure you can do thick provisioning for the disk. It's basically doing a pre-allocation of the whole disk out there so that when you're doing your log writes, it's basically not waiting for that the whole framework underneath that to grow that disk out. This actually helps performance quite a bit. I've noticed that it could make dramatic improvements out on your write workload. I do have other bullets out there that for the interest of time, I'm just going to skip them and collect the main points out there. The other thing I've ran into this very frequently, with the levels of abstractions now that you have the Postgres log files, you have the guest file systems, you have the virtual disk underneath that, and then you have the SAN infrastructure underneath that. What happens when you have so many layers out there is there is a potential of misalignment happening. Now, we all know that SAN infrastructure itself has what they call as the block sizes, and they are optimized for those block sizes. Now, if those block sizes don't align well, what happens is when you say you write like an 8K, but it's fragmented in the sense that it can only fit 4K in one block, and 4K, it has to go into the other block. So in your underlying system, the net result is you could actually potentially have 2 writes happening for your 8K write that you think is 1 write. And you don't really realize that. The only way you realize that is by the time that it takes to do that write is bigger than your average writes that you typically get on the system. So this misalignment thing can happen there are potential of that happening is pretty high. So you need to make sure that you try you do things certain way, which would help you to avoid those cases. And one of the ways I found is like, don't use fdisk anymore. The reason is like fdisk has its own header thing that it does, which kind of does a whole offset thing. So one of my frequent recommendations recently is like, when you create a disk for Postgres, do a file system on the entire disk without going through the partitioning thing of fdisk. This helps you because what happens is like when you do that, the block starts from the 0th byte on it. And basically, if that thing is that disk is starting on the 0th thing, and the virtual disk, the hypervisor would try to make sure that it tries to align itself. And if everybody's aligned together, then you don't have this misalignment problem. So this is kind of like a trick that you use to make sure that the time you spend in your I/O are the real minimum that you can get on that system. It's actually very hard to figure this out. Also, one of the things like, you don't actually really have enough tools provided to the user to say this is happening in your system because there are too many layers of storage underneath you. The other thing is like keep track of storage latencies. And this has been another common problem. Like I've seen cases where, the database is running fine and the next day the database is running slow. Something happened. And people blame the database for it. If you actually go digging down the real reason, you often find that something that was taking like 2 milliseconds to write to a particular disk now takes 5 milliseconds. You don't see that difference, like, yeah, it's 2 and 5 milliseconds, but the way it aggregates up, the whole system is slow. It's like a factor of, like, it's only 40% of the speed that you used to get before. So this kind of things happen frequently than not. So the only way you can kind of blame the right things is if you have a history of prior latencies. At that point of time, it's too late because you don't know in the past what kind of speeds you got on those SAN infrastructures. So this is one of the areas where I think Postgres itself lacks a lot compared to some of the other commercial databases. Like they could actually do some sort of kind of management. We probably need some sort of thing which would say, like, I'm maintaining this history out there, and your subsystem has now changed. So don't blame me as the database, but blame the disk that is now changing underneath me. So that's kind of thing. Like one more thing that I did find is, like, using para-virtualized driver also helps a lot, because depending on what you use for your storage I/O drivers, they have something that they call as the QDAP in the storage layer. QDAP basically means, like, when you do certain operations on a disk, it goes through a driver, and the driver basically tries to maintain a queue of how many I/O operations it's kind of like trying to process in a sequence in an ordered queue. And depending on the driver, I think by default most drivers which work on the regular disk is 1, but for SAN infrastructures, they have special drivers which has a queue depth of like up to 16 or 32. Those ones are actually designed to allow you to do high amounts of IOPS on that system. So trying to learn about those drivers that go to the storage actually helps a lot. So this is basically making sure that the driver optimization, you are getting the driver optimization. So it's not, all the things we are doing here is to avoid the problems at the hardware layer, so we can worry about the Postgres inefficiencies. Memory. Now, one of this is again a very common thing. Like, what happens? Yeah, good question. We can go over that later on. So I'm going to continue and I can come back. So most of the time, when you're creating the VM, it would prompt you for like which operating system you're going to install, and it would propose the ones that are supported for that guest OS. So moving forward, most of the virtualization technology would have some sort of hypervisor. And where does that hypervisor reside? It resides in that same physical memory, right? It's not something that it has its own special memory. So when you have this something cooked up, the memory, now traditionally if the operating system, the physical hardware has 4 gig and the VM shows you 4 gig of RAM assigned to you, something is wrong. Because the hypervisor has to live somewhere and it is using memory. So it is good to know about these things, so you have an idea of the real memory that is available to you. And the reason what I found is, like, this is kind of like things. The thing I learned is more on, like, when you do like POCs, which are on small systems compared to bigger systems. On POCs, generally you have this small setup and you create this VM, and what you would do is, like, you take a ratio of the overhead of the virtualized hardware and your ratio of the memory that you have on your VM, and say my overhead is 20% due to this hypervisor. The interesting thing I found is, like, when you take it to bigger systems, that ratio doesn't really matter a lot, because it seems like the hypervisor doesn't really, the overhead doesn't really grow higher with bigger systems. It's just incrementally higher compared to the actual memory that's assigned to the VMs. So, to me, like, the percentage overhead metric is wrong to use. Like, typically people say, what's my overhead? Oh, it's 20%. But that 20% is highly dependent on how much actual RAM you really have on that system. And that does not hold true if you go to, say, 64 gig of RAM. So be wary about, like, I've seen this percentage being mentioned in many places, even in VMware stuff, like saying, like, our whole overhead is 7%. Actually, what I found is, like, if I have a real big system, my overhead was actually less than 1% because it wasn't really needing much more than 256 meg on my 64 gig system. So it all depends. So but you need to be aware that that hypervisor is also being used somewhere in that same pool of memory that you have, and a lot of interesting things are going out there. One of the three things I'll mention is quickly is like hypervisor at the same time is actually playing with memory. It's looking at what memory you have and what memory other VMs require, and they would try to swap it around for you because it's trying to optimize that memory for your VM. It tries to, underneath that, it tries to figure out, like, this VM is running on this CPU, and this is the area of its local memory. It will try to move those blocks into that local memory so you get better low latency between your CPU and memory. So a lot of things are happening underneath you that you may not be aware of, but it's good to keep track, just be aware of that. So the reason you can figure this out is sometimes you see differences. Like, one of my read queries took this much time. 2 days later, now it's faster. What changed? It's hard to figure it out, but the hypervisor underneath that has cool things that it tries to figure out where you are running, how you are running, and it tries to optimize the memory for you underneath that. The other thing I remember that my first few slides I say, make sure you're asking for things which are sized right for your workload. The reason is NUMA groups. Like most now, I think with the exception of Intel, for most of the time, AMD had this one core which has its own bank of memory talking to another socket which has its own bank of memory. And Intel used to use this North Bridge and South Bridge, which had uniform access to all the memory. So even Intel has moved to the QPI way, which is the quick path interface, which is basically you have one socket and a bank of memory talking to another socket with its bank of memory. Now, the reason you want to right-size your VM is you want to actually really make sure that you are fitting into this one bank of memory which is local to that socket. If you ask for too much, the hypervisor will have to make sure, if you ask for, say, 2 vCPUs and 64 gig, the only way you can get that is your VM is running on this socket, but you have memory from this bank and the other 3 banks also. The problem with that is what you get is different memory latencies for all your operations, which means you don't get this standard behavior. You get this kind of like, if you run numbers, it's average. But some of your queries look real fast. Some of your queries may have to go through 3 hops or 2 hops, depending on your architecture, to get that memory out. So this can actually impact performance, and especially the measurement. The measurement are also kind of like way skewed by this effect. So by right-sizing this virtualization technology, you actually get the full benefit of the performance. And what's the trick to figure what the right size is? You figure out the number of vCPUs you want. You figure out what kind of hardware they use on the underlying structure. And if you can, you know how much memory is associated with each bank. You try to limit that memory to fit within that bank of memory, the memory bank that's associated with the socket. So by doing this sizes right, when you start a virtual machine in an virtual environment, it would actually, the hypervisors are smart to do that. Like they would start that VM with that local memory because it can fit it out there. And you would find, like, once you do these things, you actually get the best performance pretty much out of the box, and you won't have like issues to worry about. It's kind of like small things, but actually it matters a lot when you try to, you're getting 2% here, 5% here, and slowly and steadily you are getting now 2x performance gains. CPU, again, like I said, why do you want to right-size CPU? Yeah. So the size that you want to worry about is how much memory bank is local to a socket. And that depends on your underlying hardware. And typically what you will find is like whatever memory size that is local to that socket gives you the best combination of VM size, which would pretty much be out of the box, that would be the best combination. You could get more performance by going bigger sizes, but then you have to do more performance tuning. If you want to spend less time in performance tuning, start with the size that fits into a bank. So, I mean, the short answer is depends on the DIMM sizes that they use for those memory banks, right? It could be 2 gig, 4 gig, or 8 gig DIMMs. Yes, it's physical socket to the memory bank. Because remember, the way most CPU hardware motherboards now are layered in sockets and a bank of memory, sockets and a bank of memory. So if you try to fit your VM sizes within the socket and a bank of memory, out of the box you are getting the maximum performance. Because when you start the VM, the hypervisor, most of the hypervisors should be smart by now to figure out, if you want this, I can fit it into this bank, I'll start it out there. And you pretty much get the best performance because your latency is like in much smaller than what would be the worst case, which is it has to talk to the other CPU to get access to that memory bank. Yes, you can do that. In advanced property settings, there is like a NUMA group out there where you can select which NUMA group you want to kind of like say use that one. You cannot enforce anything, but you can hint that this is where you want to use. And remember, you cannot enforce it because depending on your memory, other policies that you have, that can change. So we can go more in detail on how that works. I'm going to just go forward with my other slides right now. Also, the other thing is like, if you have small databases and not really going to use a lot it's not really going to gain a lot with multiple CPUs. I have found like there are cases where a single vCPU, like a VM with just one CPU, can outperform a 2 vCPU thing on a light load cases. And when I say outperform is like, I'm trying to say you're doing some work, I'm measuring the latencies of how you can do things around that. And it's kind of like, the answer to that is like when you, especially like I said, it's an abstraction from the CPUs underneath that. So if the BIOS is showing up those hyper-threaded CPUs as 2 CPUs out there, then the hypervisor would trust that BIOS settings, and it would show you as 2 cores. It knows about it, but for the guest VM, it would think the guest would think it is running on 2 CPUs. So because of the way the things work, when you have these multiple abstractions going on, the guest loses focus on what is hyper-threading and what the real cores are. So I've seen that happen a lot. So yeah, depending on your application behavior, you may want to make sure that either the hyper-threading is turned off. Actually, I've seen cases where it also helps a lot. So yeah, depending on the workload, I would say take that recommendation. The other thing is like, if your database is lightly loaded, it's actually less. There is less overhead if you have only one CPU in your guest VM. Let's see if we got that slide. So one of the things I found is like when you have multiple guest, like VMs with SMPs in them, like you have 2 cores, 4 cores. Those things are not easy to implement in virtual environments, right? The reason is at this point of time, they have to mimic the whole motherboard to what the motherboard was using to make the coherency work between multiple CPUs. Now it's being done at the hypervisor level. Again, it's kind of like mimicking the whole motherboard at this point of time. So that's another thing that you'll find frequently that, the smaller VMs seems to work really best on virtual machines. The bigger VMs would now take more performance tuning to get it right. And the reason is like the bigger VM you have, there are a lot of things now, what was being done at the PCI layer of the motherboard is now being emulated in your hypervisor. So things like timer threads are running on all threads, so it has to do synchronization of like every CPU sees the same time out there. So there are a lot of things going out there. So right sizing, like I said, don't ask for the moon if all you want is like a car or something like that. Again, so networking is a similar thing. There are a couple of things I found which was kind of like pretty kind of neat, I would say, on that thing. So the best thing to do is make sure you have the right driver for your guest OS. The reason is like by getting the right driver, you're cutting down the CPU utilization. The thing is like also like virtual machines now have this term called virtual switches. And it's kind of like an interesting technology, and I've used them. In some cases, it's helpful. Like, unlike the old switches, which are physical hardware, they kind of emulate virtual switches in the same hardware pool itself. And depending on your workload, that may be good, because now for that switch traffic, you're not going off that server to a physical switch. So it saves you some latency cycles. But it's all workload dependent. But from a Postgres server point of view, your focus should be make sure you have the right drivers so you get the more cycles for your database itself. So that said, the other thing you want to be aware of what happens in the hypervisor that you are not aware of. So if your Postgres database server is running, the cloud admin can just pause the system, right? The whole VM stops at that clock cycle. And once you pause it, you can start it 2 days later. The VM doesn't know it at that point of time that it was paused. Once it gets back online, what happens? 2 days have passed and there was a blackout, right, from the database point of view. How do you handle that situation? I think this is kind of like the area that sometimes you would see problems happening with that. Most of the common problem I've seen is like you would start getting messages like, time has passed and queries have timed out. So a lot of things can happen because of this pause that happened on the VM. In some cases, what the Postgres developer needs to do is make the application more resilient to that. This is not that common occurrence that could happen, but there is a use case why this can happen. At one point of time, I pause the VM and actually take a backup. And the database is still running. And when you clone that VM and somewhere else, some other host, and start it up, and now it says time has passed from the time they took a snapshot of a running system. So there are use cases that are possible with this, but this can happen. So you need to be aware of that. And the other thing is like, at the same time, there are problems that can occur that the time that the hypervisor sees and the time that guest sees if they are way different, then there are some timing problems that can occur at the application layer. And this occurs primarily when you take one VM from one host and move it somewhere else, and that has a different time. And depending on your guest VM, at what point it queries the underlying hardware again to get an updated time, there will be discrepancies. So try to avoid time drift problems. Like make sure all your systems are controlled by NTP, so they are not drifting way apart. Like I actually ran into a situation recently where the only problem was one of the system was 4 hours behind because somebody messed up on setting up the time based on a different time zone. And that started causing application problems because applications which was trying to go across multiple servers now find this data which was 4 hours late, and it couldn't figure out where to put them in that application framework, and that can cause problems. So this can be a common occurrence, so try to avoid that. Using NTP in your virtual environment, I think it should be pretty much no-brainer, but even I've run into cases where I did not set it up or did not click, like, sync my time to NTP server, and I was bitten by that later on. And again, one of the common things, like I said, you have this guy called the cloud administrator who can move the resources underneath you. So your whole database server say tomorrow, can run on another system which has different CPU frequency. The net result of that is like, now we are saying queries going faster. That's a good problem to have. But be aware of that. The same thing can happen in the reverse direction also. They move to your system, which now has slower CPUs, and your now queries take longer to run. So these are kind of like common occurrences that can happen. So that's one of the reasons, like, somebody says my queries are slow, take a breathe, try to figure out what could have happened, and this is one of the things that can have happened, so you should be aware of that and question if something like that happened or not. And that said, here's another thing that I ran recently, like about a few months ago. So apparently, at least I know how VMware vSphere tries to manage those CPU reservations and other things. What it does, it takes your clock cycle and basically says, I'm giving this VM out of the 3 gigahertz speed, I'll give it like 1500 megahertz speed allocated to you. Now, so when it's playing games like that already with your VMs, I found that the BIOS was playing tricks with the ESX hypervisor by playing its own power management game. So this can be common, actually. So most modern servers actually have power management enabled at the BIOS level, where the BIOS detects how much cycle is being used, and if it's not being used frequently, it drops the CPU cycles to like half. So instead of the 3 gigahertz system, it's now 1.5 gigahertz. Now, the thing is, ESX can figure that out, but by the time it figures out, that would be the VMs would have taken a hit because of that. And I found that like this can actually happen to a level that the CPU frequency underneath, the BIOS is changing that frequency more frequently than expected, then actually can cause performance problems for the guest VMs. So this is another thing to be aware of. Like, people say like, things are not running really compared to, say, physical environments. You may want to try disabling the power management and see if that solves a problem. In my case, actually, I got like a 60% gain by just disabling the power, and I'm still like, I can't believe this can be happening. So something like, learn from my mistakes, check it out. So that said, there are certain advantages you get with using hypervised virtualization. Common setup that I've done is like, it's actually easy to set up replications. Like, you take a VM, set it up, then for replication, you can clone it and then set up the replication easily that way. Like, it's kind of like, there is a PG base backup to do that kind of thing. I don't use that a lot. I just use clone the whole VM, and then I'm going to set up the replication underneath that. So you can do some cool things also, because now we can have consistent cloning that you can do for the whole VM. So that way you have the right point, you have the knowledge of the right point you took that clone snapshot. And again, like if you're using a replication, make sure you use NTP, because otherwise, the guest time drifts can actually cause, most of the time it is aware of that. The Postgres application can sustain drifts up to certain levels, but if it goes way off, then that can cause problems. So try to use NTP for your applications frequently. So that said, coming back to my final slides, just going over the quick summary. Something I say again and again, select VM resources to fit in a NUMA group. That's kind of like the easy way to get performance out. And depending on hypervisor, hyperthreading, and other things that you use, make sure that you're aware of that. Don't think I'm running on 2 cores when it's actually 2 hyperthreaded version of that course, which is essentially just 1 core. Done that mistake a couple of times. Try to maximize the number of virtual disks you have. The more disks, the merrier. Guest OS tuning, apart from the driver stuff that I talked with, make sure you have the etc system sysctl conf tunable set. This is something that I hit frequently because like out of the box Linux doesn't have good setup for Postgres. Make sure you modify them for your workloads. Also, common recommendation, when you use makefs, use it on the entire disk, especially if it's a virtual disk. So that way that there are less chances of hitting the misalignment problem. The other thing is like when you do tune, when you tune Postgres, you pretty much tune it like you are running on a physical server. I haven't figured out any other way of saying like I can change these settings differently based on knowing that it's on a VM. All the things that I ran into are more on the level which are not controlled by the tunables right now. So most of the time when you are tuning Postgres, at least this is up to 9.0 that I have done recent work on, there are not much things different of tuning your Postgres SQL.conf tunables compared to a physical machine. The monitoring is a bit different. The monitoring, you use your standard tools. You use your IOStat, your VMstat, and other things. But one of the other things I found is like this is not the end of the story. You also need to get monitoring on your physical host on which the system runs. And sometimes I found discrepancies in these two systems. One of the times I found like, it's showing that it's running like 100% on the CPU, but if I use my host statistics, I was showing that it's only using 60% of time on a single CPU. So there are some discrepancies, and it can help you to figure out like there could be some other networking or driver-related issues going on between your hypervisor and your OS. So most of the time, if everything is set right, you won't have this problem. But you need to compare your VM statistics with your actual underlying resources as shown by at least one of the tools I use is ESXtop, which shows me the usage by that VM on CPU and how much memory it's using. And I compared that with my Linux guest VM showing what it thinks the usage is, and I do compare them. Occasionally you'll find differences, and that would actually give you hints like there are some configuration or setup or driver or some problems going on. This actually helps you to get the hypervisor thing away from you so you can focus more on the database. With that, I'm pretty much at the end of the presentation. So if there are questions, now is the time. Yep. Okay, thank you very much.